Hello everyone, myself Moushumi Shaha, Assistant Professor of Computer Science and Engineering Department from Narula Institute of Technology. Today we discuss about some problem solving basic search methods. So first we discuss about the control strategies. Control strategy decide which rule to apply next during the process of searching for a solution to a problem. Okay, so it basically decide which rule we apply during the process of searching of to finding a solution of a particular problem. The requirement for good control strategy is it should be cause motion, it should explore the solution space in a systematic manner. That means in water jug problem, if you apply simple control strategy of starting each time from the top of the rule list and choose the first applicable one, then we will never move towards the solution. And it should explore the solution space in a systematic manner means if you choose another control strategy, say choose a rule randomly from a applicable rule, then definitely it causes a motion and eventually it will lead to a solution, but one may arrive same state several times. Okay, so this is because the control strategy is not systematic. So now discuss the depth first search. Just see this tree here. The root node is A, then this child node is B and C. From B there are two child D and E. D have one child H, E have two child IJ, C have two child FG, and F have one right child K. So in depth first search is search either in order, P order or post order. That means it first search the root, then left child, then right child. So first the result of this depth first search for this particular tree is first A, it will traverse A. After that it go to the left child B, and B is the root of this subtree. So after root it will move to the left child again. So after A, B, so first it will search A, traverse A, then B. Okay, then B is the root node of this subtree, so it will move to the left child again. So the third it will traverse D. After that D is also a root node of this subtree, so it will traverse H. Okay, A, B, D, H. So after this for this tree there is subtree, there is no right child, so it will move to the parent. So this root and left child is visited, then it go to the right child, that means it visited to E. Okay, after E it will move to the left child, then right child, that means I. After it it will traverse I, then it will traverse J. Okay, so the traverse like A, then B, then left child D, then left child H, there is no right child, so it go to the parent. Root and left subtree is traverse already, so it moved to the right child. So in right child, this for this particular node, this is root, this is left, this is right, so it will be like E, comma I, comma J. So after this it will traverse for particular root, this root, all the left child is traversed. Now go to the right child. So it moved to C. It moved to C. Okay, for depth first C. Then this left child is F. So after C, it will traverse F. No left child is there, so it will traverse K. It will traverse K. So C, I, Z. So this left child is traversed. So root left subtree is covered. Now it will cover J. Okay. So for this particular tree, the traverse like, okay. Now in breadth first search, it will traverse level wise. So root node is known as level 0. This is level 0. B and C are at level 1. These are at level 2. These are at level 3. So in breadth first search, it will traverse level wise. So first it will traverse A node, that is our root. Then it will move to the level 1. So it will traverse B, then C. After that, all the node of level 1 is covered. Then it will traverse to level 2. It will move to level 2. Then it will traverse D, then E, then F and G. So all the nodes of level 2 is also traverse. Now it will move to level 3. Here it will traverse H, I, J, K. Okay. So if this, for the same tree, if we follow depth first search, so it will traverse A, B, D, H, E, I, J, C, F, K, G. And if we follow breadth first search, this is another type of search, then the traversal is A, B, C, D, E, F, G, H, I, J, K. And the difference between BFS and DFS is, the BFS visit node level by level and the DFS visit node depth wise. The BFS follow queue data structure and DFS normally follow stack data structure. BFS is slower than DFS. The BFS require more memory compared to DFS. In BFS, backtracking is not allowed, but in DFS, backtracking is allowed. Okay, these are some difference of BFS and DFS. Blind search method is a systematic control strategy. Blind search is a exhaustive in nature. These are uninformed searches. If the problem is simple, then any control strategy that cause motion and it systematic will lead to an answer. But in order to solve some real world problem, like if we must use the control strategy that is efficient. Now let us discuss the strategy using water jug problem. They may be applied in any search. So first we discuss about breadth first search. What is breadth first search? Breadth first search is a form of exhaustive search in which each of the node at the particular level is systematically explored before going to next level. That means in breadth first search, the searching will be followed by level wise. That means at first the root will be search, then it will go through the level 1, then it will move to level 2, then level 3, and so on. Okay, so breadth first search or BFS construct a tree with the initial state of the problem. Okay, here we take the water jug problem, where we already discussed the water jug problem in our previous lecture. That is, a 4-liter jug is there and a 3-liter jug is also there, without any marking, but we have to calculate a 2-liter measurement, 2-liter water measurement, by using this. So the initially both jugs are empty, so we denote 0 0. So that is our initial state. Okay, so generally all the offspring of root by applying each other applicable root to the initial state. For each leaf node, general all the successor of applying the rule appropriate. So first we traverse the root node, then we can fill the 4-liter jug, or we can fill the 3rd-liter jug, any one of them. So that's why from root, if we fill 4-liter jug, so we go to this level in the child node, level 1. Either we have moved to this condition, or if we fill 3-liter jug, then we go to this condition. So from initial 0 0 position, we can move either 4 0, that means 4-liter jug is full. Otherwise, if we step forward, so we can fill the 3-liter jug also. So this is our first step. So first in breadth first search, first we traverse this, second we traverse this level, means 4 0, then 0 3. After that, this level is completed, then we go to the leaf node again. So in leaf node, after this step, what happened? Now there are 3 probable conditions. That is, we can fill the 3-liter jug. So the condition is 4 3. We can empty the 4-liter jug again. So this condition is similar to the root condition. Okay, and we can fill from 4-liter jug, we can fill the 3-liter jug. So 1-liter jug remaining in the 4-liter jug, and the rest of 3-liter jug will fill the second jug. So from this condition, we will, so this is level 0, level 1, level 2. And if we are here, after that, the child node is, what happened? We can fill the 4-liter jug, so it became 4 3. We can empty the 3-liter jug, so it became 0 0, or we can fill from 3 to 4, so it became 3 0. The 4-liter jug filled with 3-liter water and 0. This is our next condition. After that, from this condition, we can search our next path. This is similar to that, so we can't use this. From there also, we can move our following path. And now we discuss about depth first search. So depth first search, or DFS, the search algorithm specify in order in which the state are to be examined, okay, in a tree or graph, along with the search direction. That means in depth first search, we first traverse the root node, then left child, then right child. Okay. So let us consider the situation where here we pursue a single branch of the tree until it is yield solution or some pre-specified depth as search. Or if the solution is not found, then go back to the immediate previous node and explore the other branches of depth first fashion. Let us see the transformation of water jug problem. What happened? in 0 0 we move to 4 0. This is our start state. After that we fill 3 liter jug 4 3 or 0 0. Or here this path became 0 3 if we empty this, or we can empty this jug also, so it became 4 0. So this is similar to this condition, so we follow this. Now from 0 3 what happened, we can fill the 4 liter jug. This condition is similar to that. We can empty this, so this is similar to our root start state, and or we can fill the 3 to 0 this, so 4 liter jug will be moved to 3. After that we again fill the 3 liter jug, so it became 3 3. We can empty, so it became 0 0. We can transfer this this water to this jug, so it becomes 0 3. So this is similar to the previous root, the previous child. Now this is also similar to our start state, and from 3 3 we can empty first jug, or we can empty second jug, or we can fill from 3 liter jug to 4 liter jug until the 4 liter jug is full. So we move to this direction. Now our position is, now we can empty this jug 4 liter jug, so that is 0 3. We can transfer 4 to 3, so 1 liter, after 1 liter pouring the water, this jug is filled, so it becomes 3 3. That is similar to this condition. Or we can empty this jug, so that becomes 4 0. So that is similar to this, means previous this condition. This is, so we follow this. After that from there is 0 0, so we can fill the 4 liter jug again. We can empty this jug, or we can pour this water to 4 liter jug. So this is our final state. Okay, so in depth first search, what happened, it will first search the root, then leaf node, left child, right child. The right child is not there. That is also root of this tree. Okay, so root, then left child, it moved to the left child. After that it moved to the left child again. This is also a root of this problem, so it will traverse this, this and this. So after this we can search here, then there, then it transfer here. So we move to the our final position. Now we discuss about traveling salesman problem. Consider 5 cities. A salesman is supposed to visit each of the 5 cities. All cities are pair-wise connected by road. There are one start city. The problem is to find the shortest route of the salesman who has to visit each city only one and return back to the start city. So this is the graph. This is okay. This is the aged graph. All weight. Okay. C1 is city 1, city 2, city 3, city 4, city 5, and all the distances are there. So distance between C1 and C2 is 7 kilometer, suppose, and C1 to C3 is 11. C1 to C4 is 12. C1 to C5 distance is 15. Distance between C2 to C3 is 20. Distance between C2 to C4 is 10. Distance between C2 to C5 is 12. Distance between C3 and C4 is 13. C3, C5 distance between these two is 17. And distance between C4. So this is a graph where all the connecting points have some values. Now a simple motion causing and systematic control structure could be in principle to solve the problem. Explore the search tree of all possible paths and return to the shortest path. We have to first explore the search tree for all possible paths, and then we have to return to the shortest path. This will require 4. factorial path to be examined. If number of cities grow, say 25 cities, then the time required to wait the salesman to get information about the shortest path is 24 factorial, which is not a practical solution. So now the phenomenon is called combinatorial explosion. Here we can improve the above strategy follows. Being generated a complete path keeping track of the shortest path found so far. Give up exploring any path so soon as the partial length become greater than the shortest path found so far. The algorithm is efficient than the first one, still require the exponential time, some number raised to n. Now we have to find one city. So first it moved to C1 to C2, the distance is measured there, then C2 to C3, C3, C4, C1. Okay. So the current path, first we start with C1, then go to C2, this to C3, then C4, C5, C1. So we got the distance is 60. Now if it move from C1 to C2, C2 to C3, C3 to C5, then C4, then C1, then the distance is 61. Here first C1 to C2, then C4, then C3, then C5, then C1, then distance is 73. Now C1 to C2, then C4, C5, C3, C1. So the distance is 50. After that, we follow all the possible cases. Okay, here in this path we can't go back to the this is the second condition. This is 8, 50, 53. So we have to continue like this. We have to find all possible paths and then we have to decide which one is the shortest. Thank you for today's lecture. We will, if you have any query, you can contact me. This is my mail ID. Okay, so meet you in the next lecture. Thank you all.